Today we're focusing on the circuit fault analysis of the MQB, electric steering motor control unit. We'll explain the function of key electronic components on the board, how to identify common failure points, and share a systematic troubleshooting method for this type of EPS failure. When the vehicle is driven through relatively deep water, water can enter the interior of the steering motor through this vent hole. The first step of the repair is to remove the top cover of the control board. When removing the top cover of the control board, extreme caution must be exercised to avoid damaging the internal motor, circuit board and prevent secondary damage to it. First, after removing the top cover, we will describe the 3 sockets on the cover in detail. The first socket contains 5 pins and is used for the torque sensor. The middle larger connector is the power supply connector. Pin 1 is GND, and pin 2 is 12 volts power supply. The third connector is the communication socket. Pin 1 is the CANL line, pin 2 is the CON line, and pin 3 is the ACC ignition power line. We have used a marker pen to briefly mark the definitions of several pins on the motor housing. We can now clearly see the entire circuit board. Failure of this circuit board is most often caused by corrosion due to water ingress. The main problem area is the lower right corner, which is particularly prone to water accumulation. If corrosion is detected, we will clean the corroded area, replace the surface mount components, and repair the damaged wires. First, remove the 5 screws securing the circuit board, and use a desoldering pump to remove the solder from the 4 rows of pins on the control board. Remove the solder from the pins and take out the 5 screws securing the EPS control unit. Then the steering control module can be removed. We will now test the IGBT for proper operation. These IGBTs are the core components used to drive the 3-phase motor. We set the multimeter to the diode test position to test it. Place the red test lead on the common terminal of the driver transistors, and touch the other side of each of the 3 transistor groups with the black test lead respectively. If a beep is heard, it indicates that the driver is damaged. If one group is found damaged during testing, we will either replace all the driver IGBTs entirely, or repair the individual damaged driver transistors. The small square chip on the left side of the circuit board is the pre-driver chip, which is used to drive and control the rear-end IGBTs. This driver chip is also a particularly failure-prone component. If it is found damaged during testing, we replace it directly. To further determine whether this driver chip is damaged, we need to test it using an oscilloscope. The operating data stored in the CPU of this control unit is also highly prone to corruption. If damage is detected, we will directly rewrite the data. The surface mount components on the reverse side of the circuit board near the IGBTs are also very susceptible to damage. We need to test them one by one and replace any damaged components promptly. Today's lesson is temporarily concluded here. If you are also interested in automotive EPS steering control board repair, please remember to bookmark and like our video.